Welcome to our first session, everyone. Today, we are going to learn about the fundamentals of VBA programming, which you will use for every single thing you code thereafter. I require your complete attention, as this is the most important session of this class. By the end of this session, you will know how to use the macro recorder, an Excel tool that automatically translates Excel actions into VBA code, variables, which store information, tests, which let your code choose between two sets of actions, and loops, which let your code repeat a set of actions until a condition is met. First, you will enable the Developer tab on your copy of Excel. That tab will let you start programming. Just follow the sequence of operations on the GIF if you are on PC, or the text instructions if you are on a Mac. Now that the tab is added, to get to the coding area, click on Macros. Enter a macro name, nothing that already means something to Excel such as Windows, Excel, or a name that is already used by something else, and press Create. And there we are. This is known as the Visual Basic Editor, or VBE. You can write code in there. There are a lot of windows and buttons, but most of them don't matter. Now all we need is learn what to write. Once you did write something, if you want to save it, the Excel file must be saved with the right file extension, otherwise your macros will not be saved. Excel will prompt you if you use the wrong file extension. On this slide, you can see me recording code. I am trying to delete duplicate entries in a short list. You can see the code that resulted from this on the right. You can see in the slide's name BE1, which means you should do basic exercise 1 at this point. I'll be waiting until you complete it. Done? Awesome. You probably got code that looks very much like mine, or with more lines of code if you clicked around. However, your code did not work properly on both worksheets because the macro recorder did not understand what we intended to do. All that was recorded was delete row 9, delete row 11, delete row 9, delete row 9. We'll see at the end of the session how to make the computer understand our intentions in this particular case. Here, I am recording another macro that adds headers to two columns. I then coded a macro that does the same thing as the recorded macro. As you can see, the unwritten code is much cleaner. Both codes have the same result, however. Every line of code preceded by an apostrophe is called a comment. Comments are lines that the computer ignores, so they are only there for humans to read. The macro recorder automatically places comments at the beginning of recorded macros. The equal sign here is called the assignation operator. X equals Y means X takes the value Y. The equal character assigns a value to something. You use it to write data to cells or change the value of anything at all. For instance, the line of code cells 1 equals student ID is read A1 takes the value student ID. On this slide, a detailed explanation of what each line of code does. Anytime you see VBA code that includes periods separating two things, it means you should read the things right to left to get a clearer picture of what is going on. More of this on session 3. Here, for instance, range A1.select just means select range A1. The following line of code just means the formula of the active cell becomes student ID. The last line of code means the boldness of the text in the selection becomes true. In other words, make it true that the selection's text is bold. In VBA, and indeed all programming languages, we store data in variables. You could ask why bother when you could store data in cells instead. There are several reasons for this. Cells may contain data that you would erase. This would make code much harder to understand when you could have variables with self-explanatory names instead. And it makes code's execution slower to write data to cells instead of variables. A variable has a name, which identifies it, a type, which determines what kind of data it stores, and its contents, assigned by the user. This is the line of code you use to declare a variable, which means creating the box that will store data. Dim name as type. Name can be anything that doesn't already mean something to Excel, just like with macro names. Type is limited to a few options. Since this slide's title contains PP1, you should stop and do Pass-on Problem 1. In Pass-on problems, you already have lines of code, and you swap them around until you get working code that does what you want. Option explicit makes the use of variables you have not declared an error. This is useful because it detects typos, which are otherwise tedious to investigate. This is uniquely something you write before your macro's name, as it affects the behavior of the VBA instead of the macros. Watches let you look at the value of anything, cell, variable, the result of a calculation or function, while the code is stopped. The use of watches lets you detect unintended behavior in your code easily. It seems useless now, but becomes more and more useful as your code and expressions grow larger and harder to keep track of. Alternatively, you can just place your cursor over a variable's name while the code is paused to see the variable's present contents. Operating code step by step also helps tremendously, both in understanding another person's macro, like corrections, for instance, and in debugging, because it lets you see which operations are performed, when, and in what order. Alright, now to our second topic. Tests let your code do something if and only if a condition is met. As you can see, it can work like Excel's if function, but you can also do more than one thing when the condition is met. Typical syntax is if condition then, on the next line of code your actions, on the next line of code else, on the next line of code your actions, on the next line of code and if. After and if, the actions below will be executed regardless of whether the condition was met. The RGB color standard is widely used. For instance, every single screen you use produces color using RGB. It stands for red, green, blue, the three primary colors of light, and produces any color in the spectrum by adding the proper amount of red, green, and blue. The RGB function works by stating amounts of red, green, and blue light from 0 to 255, higher is more, and returning the color corresponding to the mix. There are a few different ways to write if. The first one is to write everything on the same line of code if you only have to perform one action, if condition then action. The second one is to use else if instead of else, which means if the first condition was false, try this condition. If it is true, do the following. If condition then, new line of code action, new line of code else if condition, new line of code action, new line of code end if. You can even have more than one else if, or use both else if and else in the same if block. This is about conditions rather than if itself, but you can use logical operators like and or to make complex conditions that check two or more things at once. Just write if condition and condition then. And make it so that two things must be true at the same time, and or makes it so that at least one thing must be true. In this slide, you can see a large if block that decides the fate of a student based on their only grade, whether they paid tuition fees, and whether they have indulgence. Obviously, setting the values of the three variables differently would yield a different result. On the side, you can see a flowchart corresponding to this macro. You should now complete your second Pass-on problem. Now, on to our last and most important topic of the day. Loops let you repeat instructions while a condition is true. In this first GIF, we have a variable called rowCounter that starts containing 1, and we enter a loop that keeps going as long as rowCounter is lower than or equal to 10. During the loop, we only do two things. We activate the cell in rowCounter in column 1, which is equivalent to clicking on it in Excel, and we add 1 to rowCounter. Then we meet the when statement, which stands for while end, and ends the loop, returning operation to the beginning of the loop. So we start again. Row counter contains 2 this time. We activate the cell in row 2 and in column 1. We add 1 to row counter. We start again. Row counter contains 3. We activate the cell in row 3 and in column 1, and so forth. The end result is that we activated all cells from A1 to A10 in order. This is the structure of a loop. It consists of 5 necessary steps that must be in that order. If any of the steps are missing or out of order, the loop will not work. Can you guess what this loop does? Try to run this macro in your head, line by line. If you cannot, copy the code directly from the slide and run it from the Visual Basic editor. On this last slide, we have adapted the code from slide 15 to fit within a loop. As such, this macro looks at all students within a worksheet and applies this algorithm to display whether they pass or fail. Note the loop condition here. While cells row counter 1 different from empty. This means as long as the cell is not empty. We use code signs to indicate text in VBA, so 2 code signs with nothing between them means nothing. As such, instead of stopping after a fixed number of times like the previous ones, this loop always stops as soon as the data is over and not before. You can now complete all remaining exercises. I'll complete the last of them, public exercise 1, in front of the class for students who are physically present, and in another video for students who are not.